Welcome back, friends. This is Josh from the Redneck Homestead channel, giving you an update on the progress of the kitchen remodel here. We have the second coat of joint compound on. The first one was all sanded down nicely, and now we are working on taking out the baseboard, the force hot water baseboard that was in the quote old kitchen. We're going to replace it with new baseboard. I'll take a little more footage so you can see what we're doing. The first thing we did is we went down to the basement and we drained this zone. Actually, let me back up. That's not the first thing we did. The first thing we did is we shut the zone off. You need to stop the circulator from running, and the way you do that is you stop the thermostat from calling. For people that may not be too familiar with how these heating systems work, I'll explain for just a second how this works. This thermostat, which we all have in our homes, measures the ambient air temperature and makes a decision whether to turn the heat for that particular zone on or off. Let's say we set the heat to 60 and it was 62 in here, then there's no calling to the boiler for heat. The thermostat's not going to make a call and say we need heat because the temperature is above the temperature that the thermostat's set at. But if the temperature is set to 62 and the temperature in the room falls below 62, then this device makes a call, it picks up the phone and says, hey, we need some heat, deliver the heat to the zone. Then there's this thing called a circulator pump, and the circulator pump, it basically cycles the water through the zone, pulls the hot water out of the boiler, and puts that hot water into this particular zone, circulates that water through these baseboards here, and then the convection process takes place, brings the cold air up underneath the baseboards. The cold air is warmed by the warm air that is being given off by these aluminum fins here, and it distributes that warm air into the room and heats the room up. And of course, once a room comes up to temperature, the thermostat takes the temperature of the room and determines, okay, I don't need heat anymore. We needed to turn that zone off, and then we need to drain the zone. We take all the water out of it. I'll take you downstairs to the boiler so you can see where the drainage actually takes place. So I'm downstairs here at the boiler, and the boiler is producing heat right now, and the reason I know that is because on this zone controller up here, there's a red light next to a couple of the zones. Sorry for the shadow, my headlamp here is giving off a shadow. Let's see if I can overcome that. In any case, we have 5 zones in this house, and zone 1 and 5 are calling, which means the temperature in the room in zones 1 and 5 is lower than the specified temperature. Now the way this works is a boiler produces heat when there's a call for heat being made. It turns it on, it heats the water up to a pre-specified temperature. In this case I have it set on 176 degrees, which is as hot as this boiler will run. It produces heat and it spits hot water out this pipe right here. Okay, it's an 1.25 inch pipe. And it comes through here, and this is the supply side. The supply side is where hot water is supplied into the system. Now this is the first zone, this is the second zone, this is the third zone, fourth zone, and fifth zone. These are called circulator pumps. These circulators, when the zone is calling, will send water through the supply. Now remember, this water is coming out of this big 1.25 inch pipe, and if this zone is calling, the circulator's running, and it's sending water out into the house for the heating process to take place. Now that water has to come back because that water is being cooled off, and when it comes back, it comes through these long pipes here into this return manifold here. That return manifold pipes down or funnels down into this 1.25 inch pipe, which goes back into the return, the supply into the boiler, where the water then gets reheated and resent back into the system. I happen to know, just because I labeled the zones, third zone is foyer. Well, that happens to be where we're working, is in the foyer. I hooked up a hose to the drainage valve here. Now, 1, 2, 3 on the supply side, I don't want it supplying any more water. So I shut the supply valve off right here to ensure that no more water gets supplied into the system. Then I closed off this return valve here because I don't want any water that's returning through here from these other zones to creep its way back up here and come out the hose. I wanted to isolate the loop, essentially, is what's going on. I now have the ability to open this valve right here, which is wide open. You can see the others are closed. This will drain the system with one complication. We need to be able to displace the space inside the pipe that once had water. We need to displace that with air. I took the plug out here, and that allows air to enter in where the water once occupied. Basically just simple displacement. I did that again on this location here. So now if we were to take this hose off here, you're gonna see, kind of hard to do this one-handed and holding the camera. Hose wants to spin around, but you'll get the point in a second. There's no water in that loop whatsoever. So you can probably hear some ruckus from the pipes, and that is Rob cutting the baseboard out from upstairs with a hacksaw. Oh, there he comes. So to make a long story short, we're going to change things around, and I'm going to show you how we're going to change things around. Alright, so this segment's off and Rob's segment's off, and we have no heat in here now. So now we really need to work quickly to restore heat to this room. So here are the two new lengths of 6-foot baseboard. Still in the box, but we just opened them up. We have one other 8-foot piece. We're going to create a 90-degree angle out of these two here. So this is how this joint's going to look. We just need to solder up this last remaining joint, and we have a 90-degree angle. Well, that looks pretty tight. Oh gosh, I've never been accused of being a really good plumber, that's for sure. But try to make it look alright. Most importantly, I want to make sure it doesn't leak on the first try. Tell you what, putting this thing all together, filling it up with water and seeing a leak is no fun, because you need to drain the entire system, and then you have drippage coming out, and you cannot solder a wet pipe. It just doesn't work. So let's pray that this worked properly. Okay, this is what it looks like when it's roughly in place. The next step is to drill the hole for the supply line, and to solder up the necessary plumbing fittings and pieces that are going to supply this segment of baseboard. Alright, so we're going to connect the, this is the return from the upstairs kitchen. This is coming out of the baseboard, and then we have to go and supply the baseboard in the front hallway through this PEX, and I'm not getting in that crawl space whatsoever. Alright, welcome back, friends. The heating baseboard project is finally complete. What started out as a very, very simple project turned into an absolute nightmare last night. And I was getting so frustrated, I had to turn the camera off because I didn't want anyone to see me in the condition I was in last night. The reality is I've done this enough times to know better, but I ran out of solder in the middle of it, had to run up to Lowe's and grab solder. I can't believe how expensive it's gotten. It was $29 for a roll. I can't even believe it. It's lead-free and all this safety Sally, you know, you got to make sure that everything is EPA compliant. Oh, look who's coming over to visit. Hey, bud, how you doing? Dada. Yeah, I'm just taking a little video telling everybody about all the heat that we just put in the kitchen. So anyways, long story short, I just couldn't get the solder to stick, and I got to give this disclaimer. I am not the best plumbing and heating guy in the world, that's for sure. And I've seen guys that can just, you know, touch solder to a piece of pipe and it's like the most solid joint. For me, I struggle a little bit more with it. Long story short, we brought heat pegs up through the floor and connected it using this 90 here. And we're running it around here. This is a 6-foot length. 90'd it in the corner. Another 6-foot length, which joins up with an 8-foot length. And returns down here into the basement. Down this 90, vertical 90, into the heat pegs and on through into the front hall, which is the next project, by the way. So, thanks a lot for taking the time to watch this video. Let me turn this camera around. Thanks for taking the time to watch this. Glad you didn't get a chance to see me last night. But if you like this video, please give us a thumbs up. If you haven't already subscribed, I'd appreciate it if you would. You'll be notified when new video comes out. And until the next video, signing off.